Okay, so now we're going to go through a few example questions. So example question 1 here. So let's look at 1A. We're asked to work out the resultant force acting on a runner of mass 70 kilogram accelerating at 0.5 meters per second squared. So we're going to use the equation F equals ma. So remember, F is equal to the resultant force. M is the mass, which is 70. A is the acceleration, which is 0.5. So that's going to give you 35 newtons. Okay, so that's your first answer there. B, a lorry of mass 3,500 kilograms accelerating at 0.25 meters per second squared. So 3,500 multiplied by 0.25. Okay, so you've got to work out basically a quarter of this. So if you can put that into your calculator if you want. 3,500 multiplied by 0.25. Okay, and if you work that out, you're going to get 875 newtons. Okay. C, a ship of mass 100,000 kilograms accelerating at 0.125 meters per second squared. So the mass here is 100,000 and the acceleration is 0.125. So look at the way I've shown my working. Make sure you show your working when you do these. So 100,000 multiplied by 0.125, okay, is going to give you 125. Sorry, it's going to give you 12,500. Okay, so that's those questions done. Okay, now the next thing to do then is have a go at example number 2. Okay, so these are a little bit different. So calculate the acceleration of the following objects. So the first thing you've got to do is rearrange the equation. We know that F equals ma. Okay, so I want to work out A. If I want to work out A, I've got to get rid of m from this side. So I need to divide that side by m, and I need to divide this side by m. Okay, so if I divide this side by m, those are going to cancel out. I'm going to get A equals F over m. Maybe a better way of showing that is this. F equals ma. Divide that side by m, divide that side by m. The m's will cancel out, and I get F over m is equal to A. So question number 2 here, example number 2, part A. We need to work out the acceleration. So A equals F over m. Remember, F is the resultant force. A 1,000 kilogram car that experiences a resultant force of 200 newtons. So 200 newtons is the resultant force. Mass is 1,000. Okay, so that's going to come out as 0.2 meters per second squared. You can check that on your calculator if you want. Okay, 0.2. B, a 1.5 kilogram ball that experiences a resultant force of 4 newtons. So the resultant force divided by the mass, resultant force is 4, mass is 1.5. Okay, so that's going to give you 4 divided by 1.5, so that's going to give you 2.6 recurring, so 2.67. Now, that's really important. When you get a recurring like that, it means 2.66666. So make sure you round up your final value there, okay? Because essentially it's 2.6666 and so on. It just keeps going on and on and on. So you can either write that as 2.6 recurring or 2.66 recurring, or you can write it as 2.67. Okay, but you must not write it as just 2.66 because you have to round up the final value, because the value after it is going to be greater than 5. Okay, so 2.67 meters per second squared. Now this one, C, is a little bit more tricky. A equals F over m. Now in this situation here, you've got this cyclist. The driving or the force of thrust coming from them pedaling is 135 newtons, and the drag force is 25 newtons. So first thing we've got to do here is work out the resultant force, because remember, this is resultant force. You can't put either of these numbers in there because that's not the resultant force. So the resultant force in this situation here is 135, take away 25, so that's 110 newtons. Okay, and then you're dividing that by the mass, and the mass is 90 kilograms here. Okay, so that's going to be 110 divided by 90. Okay, and that's going to give you 1.2 recurring meters per second squared.